This is a quick off-the-cuff video to show you how to install the requirements for the ROS Toolbox. There's a page on Matlab's documentation that has all this information, but some of the steps were a bit unclear to me going through this for the first time. So I wanted to make this video to help out new members of the Cyclone RoboSub team. If you're on the Cyclone RoboSub team, you can start by opening up the Controls 2027 Matlab project. That's what I have here. When you open up this project, you should have a bunch of stuff added to your Matlab path, particularly the check ROS2 requirements function. This is a function that I wrote. It's not available from Matlab directly, but I'll show you the workarounds to get the same information if you're not using the project. So when I run this, it checks a couple things. The first thing it's checking is if I have various packages installed, the GPU coder, Simulink coder, and the ROS Toolbox. You only need the ROS Toolbox to run ROS code. However, if you're trying to generate it into C++, which is often the point, you're going to need the GPU coder for the Jetson or the Simulink coder for a Raspberry Pi. The next thing I check is the Matlab version. I'm using 2026A, and I'm going to have the various controls team members use 2026A as well. The reason for this is mainly some bugs with ROS stuff in the older versions. There's a pretty big glitch with the 2025B update 5, I believe, that prevents Simulink blocks from launching the ROS server, which basically makes it unusable. And so this version, that glitch is fixed, so that's what I'm using here. The next thing it checks here is which compiler you're using. It needs to be one of the Microsoft Visual C++ 2022 or 2019 compilers for the ROS Toolbox. You can't use MinGW. And I'll show you how to install that. That's one of the tricky parts here. You also need Python version 3.9 or 3.10. So the instructions I'm giving here will be on Windows. I'll probably make another video for people on Linux. I don't have a Mac computer, so I probably will not make a video for Macs. Good luck, guys. So here's how you get all these things. First things first for the toolboxes. To check what versions of the toolboxes you have installed, I have some code that does it here, but you can also just use the ver command in the terminal, ver. This spits out this big list of all the different toolboxes that I've installed right now. I have a lot of space on my hard drive, so I just downloaded everything. This is probably overkill, though. So first of all, Matlab 2026A, like we want here. The other thing we need is the ROS Toolbox, obviously. Here it is down here. And the other ones I'm talking about are the Simulink Coder Toolbox, which is right here, and the GPU Coder Toolbox, which is right here. If you don't have those installed, you can go to the Home tab, and then you can hit the Add-ons menu on the top here. Click on Explore Add-ons. And this should open up a little menu in a minute that I can use to download any add-ons that I don't already have. I don't know how long it's actually going to take. Oh, there it goes. Yeah, so let's say I don't have the GPU Coder Toolbox. I would just search GPU Coder, search it there. Oh, look, there it is. And there would be an install button here if I hadn't installed it already. Now, you do need a particular license to get a lot of these features. If you're on the Cyclone RoboSub team, you either have a license through UC Davis, or if you're a grad student, there's actually a sponsored license from MathWorks that we can use. So talk to me if you're having trouble with that. If you don't have a license for this kind of stuff, you're not going to be able to do this. All right. So once we have all the correct versions, the next thing we need to do is check our C++ compiler. So the code for this is mex-setup C++. And if I run this, it tells me Max configured to use Microsoft Visual C++ 2022 for C++ language compilation. Now, if you don't have something set up here, it will throw an error, or it will say you have min.gw set up. Now, we have to use 2022 here for ROS as per the requirements down here. We can see the compiler list right there. All right. So Microsoft is a little bit annoying about letting you install earlier versions. It's a bit of a pain to go through their website to try to get the installer for Visual Studio 2022. So I'm going to show you here how to install it using winget. So if I open up a terminal, let's make it a little bit bigger there. The code I'm going to use to start with is just winget search Visual Studio. So this spits out all the various products that have the name Visual Studio in it that you can get. The one I'm after is Microsoft Visual Studio 2022 Community. So I would just use winget install Microsoft.visualstudio.2022.community. And it doesn't do the tab autofill thing like it does on Linux. I'm sure there's a way to do it, I just don't know how. If you would just type that. You can also find it if I make this terminal full screen. Let me rerun the search command so it makes it bigger. There we go. So you can see here, here it is on this line right here. That's what I have to type after winget install. So it'd just be winget install Microsoft.visualstudio.2022.community, and then enter. I'm not going to hit enter here because I already installed it, and I don't want to mess with that. It might also prompt you for permissions, like admin permissions, if you need it. All right. So when that code runs, it might prompt you to restart your computer, but what you should end up with in the start menu is a Visual Studio installer. So go ahead and click on that. It'll open up this menu here, and you're going to want to hit the Modify button. What you need for ROS is this guy down here. There will be a desktop development with C++ available as one of these checkboxes right here. Because I've already installed it, it shows up right here on this sidebar instead, but it would be one of these little checkboxes right here. You would just click the one you want. Let's say I want that one, and you would hit the Modify button, and you'll have to give it admin permissions. For some of the later stuff we're going to be doing, like Unreal Engine co-simulation, we're going to have to modify some of these components here as well, but we'll come back to that in a separate video. So yeah, you modify that, you install it. You might be prompted to restart your computer as well, but next time you come back to Matlab and run Mech Setup C++, it should show a line like this indicating it was successful. All right. So the third thing you need is Python, specifically Python version 3.9 or 3.10. There are two different Python environments you can use. If you just have Python installed in your computer, like I have Python 3.14, for example, for some other coding stuff, MATLAB will find that by default. But there's a separate Python environment that MATLAB specifically uses for ROS, and you can find the path to it using this line of code right here. That's ros.ros2.internal create or get local Python. If I run this, it spits out a file path. This is the file path to the Python executable that ROS2 is going to be using in MATLAB. So let's talk about how you actually get this code to run successfully. First thing first, you have to install Python. Again, I used winget for this. I don't know if it's pronounced winget or winget. Winget sounds better, but I'm sure someone will correct me if I'm wrong. The command here is winget install python.python, and then you type the version, in my case, 3.10. This will just install it to the Python file path. If you're wondering about the path where Python got installed to, you can go to your Start menu, and you can search Python, and then you can click Open File Location. Now what it opens here is not actually the file location to Python, but the file location to the Start menu Python shortcut, which isn't that helpful. So you'll want to click on that shortcut and click Open File Location again, and now it shows you where Python is actually installed. Depending on how you installed it, it might show up in a different place. But if you use winget, it shows up in App Data Local Programs, Python, and then the Python version. So I'm going to copy this file location here to my clipboard because we'll need it in a minute. All right. So we have to tell Matlab that I want to use this version of Python, otherwise it'll default to whichever one it finds first, which in my case was Python 3.14. To do this, I go back to the Home tab and then go over here to the Settings. In Settings, you'll have all these different options here. We want the ROS Toolbox option, and we can see there is an option to specify a file path right here. Currently, it's already set to the file path I want. If it was blank or set to something else, I would hit Browse. And then I would click here and change this file path to the one I just pasted, which in my case is the app data folder. I hit Enter. Takes me there, and here's the Python executable I want, Python 3.10. I hit Open, and then I would hit Recreate Python Environment. Apply, and close. So when you do this, your path here should be updated next time you run this command to the Python executable you just selected. I also have code here to check the version. This is just a system call to check the version at my path. This is not a special bit of Matlab code. All right. So if we install all those things successfully and run this check ROS2 requirements code, it should tell us all requirements are met. For RoboSub users, I have a function in the examples folder you can use to check that. If I go and open this ROS example model over here, we can see this is a simple model that just has a ROS publisher that publishes, or here's the ROS publisher. It has a ROS publisher that publishes a standard message float using a clock as the actual data. So I should see over here a nice ramp when it runs. And here's just a subscriber on the same topic that should just spit whatever the output is right here. I'll run this. If you did all the steps correctly and are on the correct version and everything like that, this should run, and we see the data right there. All right. One or two helpful tidbits right here. Let me actually go back to that model. I shouldn't have closed it so quickly here. This is more of a using ROS thing, less of an installing ROS thing. Here is the format I like to use when I'm putting data into a message to publish. I'll start by getting a blank message right here that I use as a template message of the type I want. You can have this be a custom interface message. In my case, it's just the float 64. And then I pass this into my Matlab function that I'm going to be using to populate the message as a template. Now inside this message here, or this function here, I just set the message equal to the template. This makes sure I'm always outputting a valid ROS message, especially if I have like complicated branching logic in this function. And then for standard messages, the default field name is data, so I just set message.data to t. If this was a custom interfaces message, I would have multiple fields here to populate. I would still do this thing right here, though. So the complication is the data type here. If I go up here to edit data, and then I have this property inspector on the side here, I can click on the variable, and I can see the type here is set to bus :space SL underscore bus underscore standard messages float 64. This is the type of message that I'm using here. Basically what happens is MATLAB will create a bus structure. It's basically a C++ struct that matches the format of the ROS message, so it can be passed around by Simulink without any issues. The first time you're creating a model that has these ROS messages in it, the option won't show up here, and it's pretty annoying to attempt to guess what needs to go here. So once you've created your blank message and or your subscriber block, there's a line of code you can run in the terminal. It's ros.ros2.create Simulink bus get current system or GCS. If I run this, it will spit out for me all of the different bus types the system needs. In this case, it spits out SL, bus, standard messages, float. If I had a bunch of messages, it would spit out multiple lines for all of them. That's what I need to use in the actual Simulink model as my bus type. So I would just copy this to my clipboard here, go back up here to the property inspector for the function, select the message input, and I would just enter here bus : space, and then paste that name right there. I set that for both the input type and the output type. The only other thing you need to make sure here is that both in the blank message, the topic for the publisher and the subscriber, you have both the topic name specified correctly. In this case, just use the default my topic, and you also have the message type specified. If this doesn't match, you'll get a cryptic error. The error is not just like go fix the standard message type in a subscribe block. It's something that's less helpful than that. So just telling you now to make sure those all match. The other thing, when I actually run this, you can see these lines here get this kind of bolded look. That's because they're the buses. To get data out of a bus, you can either unpack it in a function like it's a structure, or you can use a bus selector block. When I route this message into the bus selector block, it shows right here on the top bar a list of all the different available data sets in the bus I can select from, and I can choose which one of them I want to be output using this green little plus icon right here. If I had a whole bunch of different things in this bus, it would show a long list here. I could select which of these things I want to use. I typically like leaving things in a bus when I'm passing out a Simulink model. It's just for this example because I wanted to route it to a scope that I got the data out of the bus using the bus selector. And again, if I open this up, this ramp here is just the simulation clock time running from 0 to 10 seconds because that's what I made the input right here. All right, that's it for this video. Hopefully that's sufficient for you to set up ROS blocks on your Windows computer.